Okay, so 3.5 is talking about rational functions and their graphs. So remember, rational function is any function that can be expressed as f of x equals p of x over q of x, where p and q are both polynomial functions, but q of x cannot equal 0. So the first thing it wants us to do is find the domain of each rational function. So remember, we had several restrictions, but the big ones we had to worry about was if it was a square root, then it had to be greater than or equal to 0. And then remember, if it was a fraction, the denominator could not equal 0. So let's look at number 1 there. It says f of x equals 2x over x minus 3. If I'm looking for the domain, then I know my restriction here, the reason it's not all real numbers, is because we have a fraction. So my denominator there cannot equal 0. So then I just move the 3 over. And so we know x cannot equal 3. Which means it can be every number except 3. So it's from negative infinity up to 3, not included, and then 3 on to positive infinity. Okay, as we keep going, we see here on number 2 that it's a fraction. So we know that that denominator cannot equal 0. So we're going to have to factor it. So we know it's going to be x and x. Multiplies the 5, subtracts the 4, so 5 and 1, minus and plus, and these cannot equal 0, which means that x minus 5 cannot equal 0, and x plus 1 cannot equal 0. So when you solve them, you get x cannot equal negative 1, and x cannot equal positive 5. So if you need to, use a number line. So you have negative 1, you get positive 5, x cannot equal them, which means it can be every number except them. So that means, oops, that's a positive infinity, sorry. So that means that my domain goes from negative infinity to negative 1, not included, and then from negative 1, not included, to 5, not included, and then from 5 to positive infinity. And then we can look at number 3. Same thing. It's a fraction, so my denominator cannot equal 0. So I can't factor that because it's not a difference of squares. It's got a plus sign, so we can't do that. So I'm just going to have to move the 9 over. And so I get x squared cannot equal negative 9. But when I go to take the square root of negative 9, we get x cannot equal, remember we take the square root, you get plus or minus, and the square root of a negative 9 is 3i. 3i is not real, it's imaginary. So therefore, that means there's no restriction on my domain, so my domain is from negative infinity to positive infinity.